Thank you, ladies and gentlemen, for coming to Automation Works. My name is Ronaldo Term, and this is my third term at Automation Works training facility. This term, we did a bit of industrial automation, where we learned about PLCs, which stands for Programmable Logic Controllers. The project design for this term is a CIP model, which stands for cleaning in place. Let's get this ready. Okay. My motivation when a designer goes to a client and has to design a CIP for the client always wants to see an end product. He doesn't just want to suddenly invest a bunch of money and a few dollars or a few $1,000,000 and without seeing the end product. So I came up with the idea of then designing a model that the designer can take to the client to show the client how the CIP will work as well as what it does. And then the client can decide from there. My second motivation that I also have is after a visit to Arisa, I just got that urge and excitement to learn more about industrial automation and understand more about how the designs work and what type of designs there are in the industrial automation. My problem statement: to design and build an easy-to-move PLC-controlled programmable, PLC-controlled cleaning in place system, but cleaning in place also stands for CIP, which is mostly used in the industrial automation. How a product tank is cleaned in a factory to save time, to save labor costs, as well as increase productivity. My project description. Interesting technical facts. In the early 1950s, the CIP was introduced to industrial automation. The first CIP was just a rough design of how it works, but it wasn't successful. Before the CIPs, cleaning was usually involved a lot of labor and a lot of human hands, which wasn't always clean enough. So that was running a risk of food poison, milk poison, and tanks not being cleaned out because you have to disassemble everything and clean it from the inside out. This over here is how they used to milk the cows in the old age. This is a hand sketch of a CIP, the first CIP, to clean the process, the pipes and everything that they milk the cows with. This is the modern CIP that you'll find today. My product design. This is a rough sketch of which I started with first. So before I started anything, I had to draw a design in a book, and this is just roughly how it came out. This is tanks over here, and this part over here is just valves. These two big boys over here are pumps. Here's just a bunch of names and stuff for wires, the right ones to use for the project, as well as steps on which step comes first, second, how long it needs to clean, which direction it goes after it's done. This is an image of my design, how it looks at the moment. This is my product tank, which the milk is cleaned or which the juice is made in, and then this is my acid tank, caustic tank, and my water tank. Now after the product is pumped out into the factory, it goes in through the factory goes into the bottles, to be pumped into the bottles. This needs to be cleaned. So first they take a water rinse, so they clean it with water, and then they throw the water out through the drain. And then secondly, they take the caustic to clean out some of that stuff that just stays out they clean it, and then it goes back into the caustic tank. After the caustic tank, they wash it out with the water again, just to get the caustic that's in the pipes out. And then they take an acid wash, and then they wash out the product tank with acid. And then after they're done washing it out with acid, the acid goes back into the acid tank, and then they do a final rinse with the water, cleaning the tanks and the pipes out, and then it goes out by the drain again. My Fusion designs. This is the designs I did in Fusion. This is a pump housing that I designed in Fusion. This is my product tank, which I designed in Fusion. This is a pump adapter which broke, so I just redesigned it and replaced it. This is a sketch, how it looks in Fusion. This is an adapter that keeps a wire. I had to drill a big hole in the wood so to get the plug through the wire, so for the wood, so I designed something that I can just fill up the hole so it doesn't look so bad. So yeah, that's what I designed and 3D printed for that. This is the propeller the spooler that's inside my product tank that spools the product tank, that cleans it out. Okay. This is my bill of materials. As you can see, there's quite a few stuff. Price is very expensive. Here's the valves. Cost us 1,792 rand. All of the valves. The pumps was 510, and the PLC, which is the brains of the operation, cost 2,236 rand. My digital expansion module, which I added, also cost 1,468 rand. This is just more parts of my design, my bill of materials. This is my product structure model. This is the PLC, the main component. Under the PLC is the valves and the relays, as well as the pumps. Under the pumps is the pipes and the tanks. And then between the relays and the valves is there also wires underneath them. This is my panel, how it looks at the back side of my design. These bad boys over here are terminal blocks. Now these small red pieces you can see here, are called bus bars. They're just to connect all of the terminal blocks together. Because these are all like, you can take them apart. They're just a bunch of terminal blocks that are put together and then connected through the terminal blocks. They're very not nice to work with. This is my main circuit breaker that handles the 220 volts. And this is the second circuit breaker for the PLC that just turns on the PLC, turns on and off. So 12 volts go through this circuit breaker and 220 goes through here. There's a power supply inside here that gets power from the main circuit breaker, and then from the power supply it goes to this circuit breaker, which then connects to the PLC, because the PLC cannot handle more than 24 volts. It can only handle between 12 or 24 volts. If you put 220 in it, you lose 2,268 rand. This is relays over here that I used. So since I can't put 220 in the PLC, I had to add second relays. So the 220 comes up here. Here's just a normally open and closed that just connects it. And then on top of here is the coil. So there's wires correctly going from the neutral is going straight to the coil on top, and then from the PLC goes the live to the. Now this is just bear in mind, this is just 12 volts. It goes on top here from the PLC, and then it just connects it and then it turns on. This is my program for my design project. These two over here are inputs, the start button and the stop push button or reset. These are the two outputs for the pumps. These two outputs over here are valves for the. This is the the water tank. This is the caustic tank, and this is the acid tanks valves. My product testing. Two of my pumps broke because it was too old, so it broke. The motor that I used, gearbox, broke. The torque was not enough, so it broke. One of the terminal blocks, bus bars, kept disconnecting. It didn't fit in very well, so it kept disconnecting, which kept shutting down the PLC. My modification, sorry. To solve my pump problem, I took two fish tank pumps and took their cover off and 3D printed a new housing for them, and that solved that problem. I ordered a new gear motor from Micro Robotics. They're a nice and efficient website, which solved that problem. The motor also has enough torque for my job, so that's a plus bonus. I swapped the terminal blocks, bus bars, with other ones that Nick. Where's Nick? Here. Oh, he just disappeared. Well, Nick found me some terminal bus bars, for terminal blocks that work perfectly, so that was sorted out. And just for another modification, I also just cleaned my structure a little, my wooden structure. Technical difficulties. Understanding how the process of a CIP works was, yeah, every time I read something or watched a YouTube video, it went just out of. Okay, I got stuck on wiring my panel, for my design, because like the wire's thickness and a lot of stuff changes, but the thing that I got stuck on with the wiring was my relays. I would have used different relays, but we were not allowed access to that, so we got other ones, but they were working completely different than the ones I would have used, so that kind of stuck with me. Coding the program was also a little, yeah, rough, because after wiring up the panel, I noticed something that's not going to be very well, so I had to change some stuff with the wiring, which resulted in a few modifications. So my output was originally 6, and it went from 6 to 8, which means the entire code had to be changed. So that's why it was a little bit of a struggle there. Finding the right wire thickness was a problematic. Technical successes. I was successful in solving the problem with the wire thickness by asking Justin from downstairs for the right size. I started with one output at a time and just added one, programmed it to what it needs to do, and then added one and continued until I reached the 8th output, and that just solved my problem that I had. So that was solved. To solve the problem with the components, I looked up the data sheet for the relay, as well as Justin and Nick just to explain to me how the relays work, which one to use, where the normally open close are. David from Automation Works Training Facility, who is unfortunately not here, helped me understand how a CIP works better. Okay. Acknowledgement. I want to thank Nick over there, JC over there, Tony Elmery, as well as David, for always being there for me and for always helping me when I needed them or I had a question for them. Thank you. I want to thank Justin for helping me with the wire thickness as well as using the correct colors. Thank you. And I want to thank Wynand for all his help, as well as with providing me with a digital expansion model. Thank you. So I see he's not here at the moment. My activity log. This is how I distributed my time this term. This gray over here is the theory. This is my tutorial project, design project, PPD, which stands for personal and professional development. This is the practical, and this is the professional education, which we work downstairs, next door, or where we went to sites. Links. I'm just quickly going to show you a few links. This is my YouTube channel, if you want to go and visit it. This is where I post videos and tutorials and stuff that I do, as well as hobbies. You'll see here's a line following robot that I did, here's a former project that I did, here's some Star Delta connections and a few 3D prints.
How many viewers?
If I remember correctly, it was, the last time I checked, it was around 14,000, 14,000 viewers, yeah. Okay, my website. This is my website where I post everything. All of the PPD, all of our week's theory, our tutorial project, design project, images, photos, all of those. It's posted in my website. Here's the term 1, term 2, and 3. This term 1 was the mechanical, the second term was the Discover Arduino, and the third term, which we are currently in, are the industrial automation. This is just videos of my first term's presentation, if you want to see how bad I was there. This is my second term's presentation. Okay, I'm just going to show you a few stuff. So if you can just click on Discover Arduino. Here's the theory, practical, tutorial, design project, and PPT. Let's go to theory. This is, yeah, where Nick enjoyed punishing us. This is the industrial, The first week was industry, what we learned. The second week was electrical basics, and engineering basics. The third week was control environment awareness. Fourth was automation, industrial control. Let's go to week 2 and see what I did there. Okay, this is just electricity. See, I just write a little bit about electricity, safety, Ohm's law, electricity, single phase, relays, panels, just wire thicknesses, and you know what else. A lot. Okay, let's go back. Let's go to design project for this term. This in the background over here is my wiring diagram, in case you wondered. It's not an image that I took from the internet. Okay, this is my design notebook. Just quickly going to show you a little bit. Just waiting for the internet. He's at the moment not deciding what he wants to do. Okay, it seems to be open. Well, this is my design notebook. This is where the first thing before you start with your design is you need to get a design notebook, and then you need to plan your design. How you're gonna build it, out of what, the process and everything, where it's gonna be used, why you want to build it, is it a need for it, as well as motivations. There's designs or tools that you're going to use that are not efficient and not supposed to be used this term, like 3D printers. Then there's there's a few links, and there's steps of how your project will work and what it will do in the end, as well as improvements and a lot of other stuff as well. Let's go back. Let's just quickly go to PPD. This is where JC gets involved, our activity log, which we need to fill in every day of what we did today. And this is the Monday morning meeting, which we did every Monday morning. These are my marks, admin, which is just some admin, and this is my process. Let's quickly show you my marks. If you mind to do not judge me, please. Let's go there. Yeah. Okay, this is my marks. This is week 1, week 2, 3, 4, 5, 6. Anyway, you get the picture. This is just this is effective comment and activity logs. Just mark show, and then JC just adds some stuff that we did wrong or did good. Okay, and yeah, that's my website. Please visit it and tell me what you think about it. Okay, this is some of the the links that I visited, websites on the internet that helped me also. One of the websites helped me to understand the CIP better, as well as the 5 steps of a CIP, because I didn't know it had 5 steps. I thought it just washed out the product tank and then you have done with it. The link showed me why you need to use a CIP and what's the difference between just cleaning with your hands and using a CIP. Another link helped me understanding logic gates better, and as well as ladder gates, because this is just a demonstration video. Start ons gou. Hier gaan die lys lig hê. Ratching lys lig hier aan. Terwyl hy werk, en op die oomblik loop die water in die produktank in. Dus nou gaan die water hier inloop, dan gaan hy nou uitspoel, en dan nadat gaan die water gaan die water laat uitpomp. Dan gaan die water al die pad deur terug gaan na die drain toe, of in hierdie geval terug na die watertank toe. En dan gaan hy die caustic vat, en dan gaan hy die caustic uitpomp, en dan terug in die caustic tank, en dan gaan hy weer water rins vat. En ja, dan gaan hy met die acid begin, en dan gaan hy net 'n final pre-rinse doen. Okay. Hier is die terminal blocks. En hierdie goedjies hier binne is die busbars. Baie nie lekker om mee te werk nie. Hulle disconnect nogals baie frequently, veral as jy die verkeerde gebruik. Hierdie is die main circuit breaker, hierdie ene, waar die 220 ingaan. So op die oomblik is hier so 'n 220 in. Ja, ek sit nou speel met my vinger by 220. En ja, hier is die 12 volt wat van die power supplier afgaan, wat hier so binne sit. Hy sit hier so binne, en dan gaan hy nou al die pad na die
hierdie circuit breaker toe en die circuit breaker is geconnect na die PLC. Want die PLC kan net tussen 12 en 24 volts vat, hy kan nie 220 handle nie. So dis hoekom gebruik ek separate relays wat 220 onderin gaan en dan gaan die 12 as die PLC geconnect na die relays hierbo. En dit is hoe hy dan oorswitch. Ok, ek gaan gou vinnig die code net check. Program. Ok, hy is op stop mode op die oomblik. Program. So hier is die program nou wat op die PLC is op die oomblik. Ons het die twee inputs, hierdie B2 en B1. En dan gaan ons die uit. Dan status vir die program. Yes, oké. En nou hier agter gaan ons nou gou vinnig die ekskuus hierso. Ons net gou vinnig die knoppie start button druk.
This is my poster for my design of this term. Here's my QR codes for my YouTube and my website, as well as my email and my phone number. There's a picture of me, the designer of the model, a few designs, my name, a term, as well as the product name. Thank you all for coming. Do you have any questions for me? Okay.